It gives me great pleasure to introduce Dr. Michael Webster, an expert in the field of coral reef science and conservation management. Thank you.
Well, good afternoon, everybody. I'm just going to jump straight into my talk today and begin with really posing a big question that we worry a lot about when we're working on coral reefs. And it's this question, which is, how can we save them? And the question here is framed in a particular way because there really is a question of how can we do it? And if we don't try, we actually have some pretty severe concerns we're not going to succeed. And so as somebody who works on coral reef conservation on a daily basis and thinks about these systems, we're really trying to figure out what are reasonable answers to this big question. And I don't know, has anyone here heard about coral reefs in the news recently? Can I see a show of hands? Heard anything about, it's pretty much everybody. Probably had to do with something like this. So in the videos I just showed you a moment ago, the corals had color to them. They were browns and greens and oranges. These corals in this photo are stark white. And this is a process called coral bleaching that's been in the news a lot in the last few years. And what it is it's a response of corals to really extreme stress. The stress usually is that the water is too warm for too long, and they go through a process called bleaching. We'll talk a little bit more about this later on. But what's happening is that people are really starting to notice that something is wrong on coral reefs. And it's wrong on coral reefs all over the world in many different places under many different conditions. And it's really adding up to what we see as an existential threat for coral reefs. Are coral reefs going to continue to exist in 100 years or 1,000 years? Or are we doing things today that's really going to prevent that? As a coral reef conservation organization, we want to figure out, okay, given that all these changes are happening, what can we do about it? So what I'll argue in my talk today is that there's really two key pieces we're going to have to figure out in order to save coral reefs. To save coral reefs, we've got to figure out mitigation and adaptation. Mitigation here is mitigation on climate change. This means figuring out the problem we're creating on the planet by putting so many greenhouse gases into the atmosphere and changing our climate. If we're going to save coral reefs, if we're going to save any ecosystem, if we're going to save peace on Earth, we're going to have to figure out how to solve this problem. And the good news is there's more and more action around the world of people trying to solve this problem. We've got, I think, all but one country in the world has now signed on to the Paris Accords. That kind of leadership would have been unprecedented a decade or two ago. We also have communities, we have businesses like this business, as well as other municipalities and individuals beginning to take action on climate. This is really good news because this is one of our chief problems as a species going on into the future. We're going to have to solve this eventually to get things right for coral reefs, as well as to get things right for so many other ecosystems and things that we care about. But in the meantime, we're already locked into change. We've already put enough greenhouse gases into the atmosphere. We've already done enough changes to the planet that we've got to deal with those changes that are already underway. And for ecosystems like coral reefs, those changes that are already underway are causing really big problems. And we can't just stop them. Even if we stopped all of our greenhouse gas emissions today, we'd still be locked into that change. So one of the key questions that we have for coral reefs is, how do we manage that process of change? How are the coral reefs going to adapt to a changing environment? And what can we use from the science of biology or evolution that can help inform how we do conservation work in order to promote that adaptation? That's going to be the focus of what I'm going to talk about today. Before I go too far down that road, I wanted to introduce the primary character we're talking about. We're talking about coral reefs, and coral reefs are defined by the presence of corals. This photo shows actually a whole bunch of corals. You can see one in the center that's roughly vase-shaped. Pretty much every single surface on the bottom in this photo is covered by some form of coral. A lot of people have no idea what a coral is. If you haven't been on a reef, if you haven't spent time around them, you may not have any direct experience. But even if you have, what is this thing? Is it a plant? Is it an animal? Is it something else? Most people really don't have that close of an intimacy with this organism, and I actually want to spend a few minutes talking about it because I think corals are one of the coolest organisms on the planet, and I think there's some things that they do that are downright miraculous. And by understanding that, one, it's just interesting to know about the corals, but two, it helps us think through what we can do to help protect and save them. So first of all, let's take a little bit of a closer look at some coral. So this is a close-up of a colony of coral. When you see a coral head like that one in the last photo, it's comprised of thousands of individual little animals that together constitute a colony. That colony consists of these things, which you see in the image here. These are called coral polyps. They're the circular shaped structures here. Looks a little bit like a sea anemone. So this organism is an animal. And it's an animal that lives in this colonial form. So one animal will settle onto a reef at some point in its life. And as it grows, it'll bud off a new individual. And then those two will bud off new individuals and new individuals. And they build this sort of spreading colony of clones across the reef. And so when you look at a coral colony, it might be thousands of these individual animals, but collectively they're working together as a colony. Now, in order to survive, these animals have figured out a couple really interesting things. You can see in this short video here that there are small creatures moving around in the water column. These are little shrimp-like animals swimming in the water, and the coral will be delighted to eat these. They've got these amazing tentacles with stinging cells that can paralyze one of these animals if it happens to run into the coral, and then they can quickly swallow it and eat it. They're actually formidable predators on the reef. But most of their energy on a daily basis doesn't actually come from being a predator. Most of it actually comes from small plants that live inside its tissues. The corals are basically farmers. And what they've figured out how to do is how to grow little tiny, tiny plants inside their tissues that provide the coral with food. In return, the coral provides those little plants with its waste products, and inside the coral, they're able to recycle that energy, and both have a nice place to live, and both can grow. So let's take a look at a cross-section of one of those polyps. What you can see here in the circle blow-up is some of the tissues of the coral that show, it's labeled as zooxanthellae. Those are those little tiny plant-like organisms that live inside the coral. They're actually what give the coral its color. Corals are naturally usually clear, but they have these algae that grow in their tissues that provide them with the food, and the color you see when you see a coral is usually those little organisms that are providing the food. Now, coral reefs grow in places that tend to be very low in nutrients. They're basically ocean deserts. They're in the tropics, the water is clear, and there's very little nutrient in the water. Coral reefs have had to be really, really efficient to be able to grow there. And one of the things that corals have figured out how to do is by internally recycling those nutrients, they can be very efficient. They can also figure out how to grab space and occupy space to compete with other corals. And the main way that a coral will do this is by building a rocky skeleton that it uses to overgrow other corals and take over space on the reef. You can think about like in a forest, as trees grow up, they grow over other ones and shade them. The trees are looking to get to the canopy to get up to the light. Corals are doing the same thing on a reef, but they do so in a pretty remarkable way. They'll take ions of calcium and ions of carbon out of the water column, and they'll use it to synthesize what is effectively rock, calcium carbonate. And if you look at the bottom of this coral polyp, then the cross-section, it's all white under there. That white is rock that's made biologically by the coral. That rock gives it a solid place to live. It also gives it the ability to overgrow other corals in that ecosystem. So in a place where there's almost no nutrients, in a place that's effectively a desert, corals have figured out how to grow pretty quickly and to base their growth on building these rocky structures. So that when you go to a coral reef, if you ever have a chance to visit one and you look at the structures around you, you'll see structures like this with huge coral heads, all these fingers growing up to the surface and all these plates growing off in the background. All of these structures are being built by that process. They're being built by that interaction between the coral and those little tiny plants inside its tissues in order to build these massive rocky structures. This is what makes a coral reef a coral reef. This is what makes the habitat for all the animals and all the other organisms that live on the reef, the fish, the turtles, the sharks. Everything are there because corals are building all of this structure, which creates a home for everything else. Now, most people tend to think of corals as very slow-growing animals, and if you were to sit and watch a coral, yeah, you wouldn't see much growth over a period of time. But with millions of corals building rocky structures over hundreds and thousands and even millions of years, what they can produce is actually quite astonishing. So you don't just get big coral heads like this. Corals also build entire islands. This is an atoll, which is a special kind of island found in the tropics. It is special because that island is built entirely out of coral. And the corals are making those rocky skeletons which pile on top of each other, on top of each other, and on top of each other. And in doing so, they can keep a reef right up to the surface of the water that can exist for millions of years. And in doing so, the wind and the waves and the currents will pile up some of that broken rubble from the coral over time, and they'll make beaches, and they'll make entire things like this island here, a coral-built island. If you pan back further and look at what corals can do, they can build entire structures like this. This is just a section of the Great Barrier Reef. You can see the greenish colors offshore. Every single one of those reefs is made by corals and just a few other organisms that can do this trick of making rock out of water. The Great Barrier Reef is something like 1,400 miles long. It can be seen from space by the naked eye. This is the largest biological structure on the planet. And it only exists because of these miracles where coral has figured out how to work together with these little tiny plants in their tissues to build rocky structures in a place that would otherwise be a desert. So in my opinion, corals really are the key to the reef. They build it, they maintain it, they provide the place for everywhere else to live. The problem we're facing around the world is that the corals themselves are in decline. And we have to ask ourselves, what happens if the corals disappear? And more importantly, what can we do to make sure that doesn't come to pass? There's a lot riding on getting this right. There are all the different kinds of life that rely on the coral reef, millions of different forms of life. It's probably the most diverse place on the planet. There's also hundreds of millions of people who rely on the coral reef on a daily basis. Whether they're people who live in a place like this and like to go and see a reef and experience the wildlife there, or the people who live in that place who are building their economy based on that kind of tourism. Whether it's people who rely on a coral reef for fisheries and the fish that it attracts and that can live on the reef, or islands that exist only because of the coral and the reef itself, which protects coastlines from things like big storms. And then the last thing that's really super important about coral reefs is it looks like a good fraction of our medicine chest of the future is going to be based on coral reef organisms. There is huge research going on right now to find new drugs on coral reefs. They're finding cancer drugs, they're finding antivirals, they're finding painkillers, they're even finding new classes of sunscreens that are coming from the millions of different kinds of organisms that are found on the reef. We all have a stake in this future, and many, many people on the world have a very direct stake for their economic livelihood and for their food security. And it really doesn't take very much for coral reefs to deliver all of this. All they need is some clear water that's warm and that's shallow, and they're going to flourish. Every place in the world, in the tropics where there's shallow water that's clear, we get coral reef formations. In addition to that, corals really like it when there is some grazing going on the reef. There's a lot of fish and other organisms that do a really good job of keeping the reef clean. In order for the corals to grow and flourish, they have to compete with some other organisms for space. In particular, they're competing with things like seaweeds that would otherwise overgrow the corals. They can grow a lot faster. Fish like this parrotfish scrape the bottom and keep it clean, making a much better environment for corals. So it's not a very complex recipe. Clear, warm, clean, shallow water with some grazing. The problem is that wherever you find people near reefs, there are a series of repeated things that people tend to do that cause problems for the reef. This is a photo on a beach in Maui after a rainstorm. And what you can see in this photo is there's this plume of sort of orangey brown water that's coming off the land and flowing into a coral reef environment. That water is bringing sediments, it's bringing nutrients, it's bringing toxins, all of which are very bad for the corals. It smothers the coral, the nutrients bring in, they cause proliferation of things like seaweeds, and you can see in this photo there's green on the beach. That's something you might see in California, which has highly productive coastal oceans. In a coral tropical reef system that's supposed to be something of an ocean desert, this is a sign that something is wrong. The seaweeds are getting out of control in this system. This is bad news for the corals. This kind of pollution, whether it's wastewater or development or mining or any other form of pollution in coastal waters, is something that gets repeated time and time again when people have communities that are based near coral reefs. On top of it, people have a taste for fish. and coral reefs can support fisheries. They can also be easily overfished, and overfishing becomes a real problem when people begin to take those grazing fishes out of the system. Basically what happens is that cleanup crew, that grazing group of fish that keep the bottom clean, when it's no longer there, things like seaweeds can grow more quickly and more effectively, and they can overshade and they can begin to take over the reef. If you're polluting the reef at the same time and dumping a bunch of nutrients in it, the effect is like putting Miracle-Gro on the seaweeds. The seaweeds can grow, they can take over, and if there's nothing to eat them, you get this transition from a coral reef to a seaweed reef. And when that happens, it starts to become game over for the reef. Remember, the corals are building all the structure. They're making everything for everybody else to live on the reef. Once that process stops, the reef begins to simplify and flatten, lose the diversity, and lose those values. Excuse me. So those two things are playing out at a local scale. At the same time, we've got another set of changes playing out at the global scale. This is a temperature record, average global temperature for the last century or so. Everybody knows this story. The black line here is average temperatures. Blue bars pointing down are years when the temperature was below average. Red bars pointing up are years when the temperature was above average. You don't have to be a statistician to see what the pattern is here. The world's getting warmer and warmer and warmer. And this takes us up to 2016. The most recent projections for 2017 are that it's going to be either the warmest year on record or at least in the top 3. The pattern is continuing going forward. When the water gets too warm, it is bad for the corals. I told you a minute ago that one of the things that the corals want is warm water. They do want warm water, but it turns out they're a little bit fussy. They want the temperature to be between here, and not above it and not below it. And the reason for that is that living in the tropics, the weather is actually very predictable. From one year to the next, from one season to the next, it's a very predictable environment. And corals over evolutionary time have figured out how to fine-tune their relationship with those little tiny plants that live inside their tissues so that they have it working just perfectly. They have it optimized to get the maximum amount out of food, and everybody is super happy with that relationship. But that relationship is partly dependent on the temperature. And when the temperature changes, the relationship between the corals and those little tiny plants begins to break down. And what happens inside the coral animal is that those little tiny plants start to produce toxins that make it poisonous inside the body of the coral animal. In a last-ditch effort to survive, what the coral will do is it'll actually expel all of those little plants. It'll basically throw away its crops in order to survive from the toxins that would otherwise kill it inside its body. Now remember, those little tiny plants are what give the coral its color. And what you can see here is that on the photo on the left, the colors are a pretty orange color. In the central photo, they've turned white. That whitening is called coral bleaching, and it's what happens when the relationship between the algae and the coral break down. Now you think about it from the coral's perspective, most of its food is coming from this algae inside its body. Once it expels it, not only is it already stressed from the high temperature and what's happening inside its body, now it begins to starve. In many cases, what happens is that those corals will then die. And if you see on the picture on the right, these corals have died from this bleaching event, and now they're fuzzy and sort of ugly colors. The seaweeds are beginning to take over. This has shifted from a healthy coral reef to something that's dead in a very short period of time. This is directly tied to temperature, and we're seeing this more common because the Earth is getting warmer. These things, as they're playing out on coral reefs, are causing major, major changes. You can think about these changes and say, okay, well, maybe this place or maybe that place. But if you begin to actually look at what happens to a reef over time, it's not a minor shift from what reefs used to be to what they're becoming in places around the world. This photo was taken in 1978 by researchers who were working in Discovery Bay, Jamaica. Now in the 1970s, people weren't really worried about the future of coral reefs. Coral reefs were doing fine, but they were interested in trying to understand them. And so what these researchers wanted to do is they wanted to see, hey, how does this reef change over time? How do the species change? How does this change? How does that change? And one of the common techniques that researchers will use is they will go and they will measure the same patch over and over again to see what changes in it. And so what they did in this case is they built a quadrat for counting what was inside this patch, and they put this little stainless steel pin into the reef. Can you see it in the foreground there at the corner of the quadrat? They drilled a hole into a living coral, they took a stainless steel pin and they tapped it into that coral so that they could come back year after year and they could put that quadrat in exactly the same place. Now that's really useful to us now because we can say, okay, what does that reef look like today? If we can go and find that little stainless steel pin, we can see how this reef has changed. Here we go. Do you see the pin? This is the same place 30 or so years later. So here it is where it's got all of its coral. This was a very typical reef. This reef got hit by a hurricane, it got hit by disease, it got hit by coral bleaching. And what happened is that in 30 years, it went from this thriving ecosystem that was providing all these benefits to the community and all these benefits to the wildlife to this. Not only is it ugly, it doesn't provide the structure. It doesn't have places for all those animals to live. It doesn't block the waves. It doesn't bring in tourists. This is a huge catastrophe for the community that relies on this reef. It's also a catastrophe for the wildlife that used to rely on that reef. And this is the story we're seeing repeated over and over and over and over again around the world. This is why we are so concerned about the future of coral reefs, because this is no longer a coral reef. It's an ecosystem. It's got some life in it and different organisms, but it does not have what the coral reef once had. Okay, so I might have depressed you a little bit with that. The basic narrative around coral reefs is that one. And a lot of people are pretty freaked out about this ecosystem, and some people are feeling some dismay. I want to shift gears now, though, and talk about why we should be optimistic. Because I think there are actually some really good reasons to be optimistic, especially if we can use the information that we have to make smart decisions about how we save coral reefs. And so I'm coming back to my simple equation before: mitigation plus adaptation equals saving coral reefs. I actually want to dive into the adaptation part now. I want to take a look at what is it going to take for adaptation. I'm going to argue that it's got 4 parts. It's going to take making sure that we do enough work to save coral reefs at the community scale in a way that protects the diversity of reefs, protects their connectivity, and is doing it at an appropriate scale. So I'm going to go through each of those pieces one at a time, and then I want to put it together in a way that sort of describes how we're thinking about how we're going to save coral reefs going forward. So the first piece is communities. My organization's mission statement is uniting communities to save coral reefs. Our specialty is working with communities that rely on the coral reef for fisheries benefits, for tourism benefits, for other benefits, who are trying to figure out ways that they can structure their economic activities in order to get those benefits from the reef without causing the reef to decline over time. The good news is that communities all over the world want this. They want this kind of solution. They're looking for ways that they can protect their reefs, and they're looking for those solutions. So what we've found is that there's actually many more communities than we're able to work with who are asking us, hey, can you help us do this? Can you help us find this fishery solution? Can you help us find this pollution solution? There is an extraordinary number of people who want to do this. This particular community is in Fiji. In Fiji, this community actually owns their reef. There's a different property right history in Fiji where the community owns it. This community has chosen to take a huge fraction of their reef and protect it because that's what brings in the tourists, and it also protects their interests for the future. They're able to benefit from fisheries, they're able to benefit from tourism economy by protecting their reef. They found this kind of solution that's durable and stable over time that provides them with the benefits and protects the reef. This kind of system is replicable in community after community after community, provided those incentive systems are there, provided the interest in fisheries, the interest in economic development around tourism. That's the raw material we have to work with many communities around the world. When we do this kind of project with a community, that community can change the health of their reef. They can make it a better reef for corals, they can make it a better reef for fish, they can address those local problems, and in doing so have more coral that's healthier, that's doing better in that particular patch. The next piece is we need to be working with the diversity that we've got on coral reefs. It turns out that coral reefs, as I mentioned before, are one of the most diverse ecosystems on the planet. That diversity is really important when you think about going through a process of change. If you think about corals on a reef, you can think about an average coral. And an average coral is the coral that's bleaching. The average coral is the coral that's having trouble as the environment is changing very quickly. But the more we look at reefs, the more we realize that the story of coral reefs is not about the average coral. It's about all of the diversity of different corals that are on the reef. Some corals are already really good at living in hot water. Some corals are already really good at living in polluted water or really strong wave forces because they live on reefs that have had those conditions for hundreds or thousands or even millions of years. The corals on this picture live in a very strange reef in coastal Honduras that sits at the mouth of a river that's got extremely polluted water. This is one of the clearest days ever on this reef. It's entirely covered with live coral in a way that has most coral biologists scratching their heads saying, what in the world is going on here? How can these corals live in this environment where we would expect them to have already died and been gone? The true answer is we don't know yet, but what we do know is the more we look, the more of these unusual corals we find. The more we find corals thriving in these really extreme environments, and what that tells us is that there are already tons of corals out there that are able to live in the conditions we're creating on reefs now and the conditions that are coming for reefs in the future. So these particular corals may be some of the best corals for future reefs. The next piece of the puzzle is connectivity. That's all great for those particular corals in that particular place, but if they're stuck on that reef, it doesn't help any other reef. So when you think about that reef that I showed you in Jamaica that's been so damaged by the threats that have played out there, how does that reef get repopulated with new corals? How does it come back and become a coral reef again? Well, if we go back to some of the biology on corals, remember the corals are living in colonies glued to a rock on the bottom sitting next to clones. That's a very bad situation if you want to reproduce sexually. When corals reproduce sexually, they've figured out a solution for this, and that is they just release their eggs, which is what you see in this video here, or their sperm, into the water column all at the same time. Corals across a whole reef will release this at the same time, and in doing so, their eggs and their sperm mix together in the currents, and occasionally the right egg and the right sperm come together and they make a little tiny baby coral. Now that's important because it's happening in the water. It's not happening on the bottom. And those baby corals are pulled away from the reef in currents, and they might spend a few days, a few weeks, even a few months floating around in the ocean before they find a reef. They come down to the bottom, they glue themselves to the bottom, and they begin a new colony. What that means is that those unusual corals in places like that reef in Honduras, when they reproduce, their babies can get to this reef, and this reef, and this reef, and this reef, and this reef. And so if they're doing something right, if they've figured out something that allows them to thrive in conditions where other corals can't, they can get their babies, who are likely to inherit that same trait, onto the next reef, and the next reef, and the next reef, and the next reef. So if we've got a diversity of corals that are out there, and those diverse corals can get from one reef to another, we've got the beginnings of a solution for adaptation. The next piece of it is around scale. If you do something like this and you protect one reef, like this community in Honduras that I've shown in the yellow dot here, that by itself can produce that local benefit. But if that local benefit can't get to other reefs, then that system is going to be unstable. It's going to get hit by a storm, it's going to get hit by a bleaching event, and that reef is going to get wiped out. It's that process of recolonization at a big enough scale that is going to allow adaptation to happen. So this region in the map here, thank you Google Maps by the way, this region in the map here shows the Mesoamerican reef, which is part of the Caribbean, and it connects Mexico with Belize, with Guatemala, and Honduras. These reefs are probably interconnected with each other. The babies from one place can get to another place. And so some of the work we've done in Honduras has said, okay, let's move from one reef, and let's start thinking about putting together a network of reefs in Honduras, where each of those reefs, each of those communities who rely on those reefs are making decisions about how to manage their reef that create a better environment for corals and a better environment for the rest of the wildlife on the reef. They can get their local benefit, they can provide that benefit to that reef. In doing so, we can begin to build a network. That network of healthy reefs then can be a source of baby corals that can move from one reef to another reef to another reef to another reef in that network. Now Honduras is probably a little bit too small for this because Honduras could get hit by one big hurricane or something like that. But it turns out that the connectivity is pretty good with places in Mexico and Belize and Guatemala. And if we start looking at the work that's going on in each of those other places, you can start to imagine a networked system here where there's enough reefs with enough communities working to protect them that include a lot of that diversity that's present in the system that's connected from one reef to another. And it's this kind of solution at this kind of scale where we're going to get adaptation on coral reefs. This kind of network system has lots of the diversity, lots of the connectivity, and it's big enough to protect it from risk. We call this system an adaptive reefscape, and it's basically a concept for how do you build these networks repeatedly around the world in ways that allow the reef to adapt to the change that's coming. So that's the in-principle argument. Build the adaptation network. And the biological information that's out there, the evolutionary information that's out there, all says this should work. And we like that because it helps give us an idea of what the solution should be. But we wanted to go to the next stage and say, okay, can we do better than it should work based on first principles? Can we actually begin to tinker with it and understand it in greater detail? And so we've worked with a bunch of different researchers at different universities to say, can we take what we know about corals, how diverse they are, how much they move from one place to another, how good they are at inheriting the traits of their parents, and can we begin to ask very explicit quantitative questions about their ability to adapt to change over time? Now, this is a horrible, ugly set of equations, and I'm not going to pretend that I can explain the equations to you. But what the equations have done and what the researchers we're working with have done is they've taken all of this information and they've built a mathematical coral reef region that has a bunch of different reefs with different diversity, with different environmental conditions that are connected to each other in the way that corals are connected to each other. And we've used that to begin to ask the questions, okay, realistically, the world is changing really, really fast. Are corals capable of doing this? Are they able to actually adapt fast enough to be able to deal with the conditions, or is it a pipe dream? Maybe they can adapt a little bit, but it's just going to be too slow, and the pace of climate change is going to overwhelm them, and we're going to lose coral reefs anyway. Well, the good news is the answer, looking at this question, and we've looked at it a variety of different ways, always seems to come out to this. Yep, they can adapt, but there's always an if. And the if is about what we choose to do now and over the decades to come. Basically, the answer is corals can do this so long as we take action and we try and find solutions that can work for those corals. And that if contains two things. One, it says if we are hell-bent on burning every last ounce of fossil fuel on this planet, it's probably not going to work. We actually have to get onto a reasonable trajectory on climate in order for coral reefs to really have a good shot at being able to adapt. The other piece is we've got to figure out this local management problem. And by building these adaptation networks, the adaptive reefscape that I described a moment ago, that's going to go a long way toward providing the raw material for adaptation. So if we do those two things, we have good reason to believe corals are going to be able to make it through this. Okay, so if we think it's going to work, can we use that same information to figure out the best way to do it? Because when we look at doing coral reef conservation work in a region, we've got lots of choices about which reefs should we work on, which communities should we work on, which countries should we work on. How do we deploy our resources in a way that's going to lead us to the best bang for our buck? And so that's interesting, if you go to the coral reef science literature, there's a whole bunch of different ideas about how to do this. How do you, the basic question here is, how do you pick your reefs for the best conservation benefit? And so if we're thinking about building a network, we could look at this network and we'd say, okay, let's find the best reefs in that network and let's protect those. That's going to be our best strategy. So one strategy would say, go to those reefs that have really high coral cover. If they've got high coral cover, clearly they're good for corals. Those are probably the reefs you want to bet on. That's one thing you could do. There's another group of researchers saying, wait, hold on a second. There's a different set of reefs we should be focusing on. Let's go to the ones that are naturally cooler. The cooler reefs are going to be most buffered against climate change. If we can protect the coolest reefs, those are the ones where the corals are going to have the best shot because it's not going to get as hot. That's what we should be doing, climate change refugia. That's an interesting idea. There's another group saying, wait. No, it's the warm reefs we should be going for because the warm reefs are the ones that already have the corals that are good at living in hot water. Those are the ones you want for the future. And then one of the things that we've been postulating for a while is that any one of these kinds of strategies that's narrow is probably too narrow given the uncertainties we're facing. And what we've been thinking is perhaps we should be looking at this as a portfolio of different kinds of reefs. That's where we get that diversity that I was talking about earlier. Reefs with different kinds of environmental conditions in a diverse portfolio might give us a better end result. So we've been able to use that same mathematical modeling framework to evaluate different strategies like this. Pretend you're God and you can design your conservation network and you can design it from zero and then you can play it out over time and see how well it does. So you can do a bunch of model runs. These are different tracks of model runs for what performance looks like. Here performance is measured in coral cover at some time in the future, model runs for those different strategies. Each line is a different strategy. You've got a hot reef strategy, a cold reef strategy. There's a strategy that says, no, go hot and cold. Put those two together. That's going to be your right strategy. And then there's a series of them that are built on some kind of diversity portfolio. There's a gradient strategy, which just says, just evenly space your reefs. Don't worry about what's there, but just space them evenly. There's another one that says, look at how much diversity and environmental conditions are out there and deliberately design the best diversity portfolio you can. And then the last one says, just pick them at random, which is another way of incorporating a lot of the diversity in the system just by chance. So the kind of results we're getting look like this. We've done this analysis many, many different ways with many, many different assumptions about how corals can move around, about how their genes can spread from one generation to another. And the answer is basically always the same answer. The diverse portfolio strategies perform the best. Given the uncertainties, given the way things are changing, whenever you try and outthink the system and come up with a really smart answer, it's going to be the hot reefs or the cold reefs. As soon as you pick a narrow set of predicted winners, that's when your performance goes down. When you assume that you don't get to know the answers, but that you want diversity in that system to cover your bases, that's where your performance is the best. So now what we're doing is we're taking that kind of information and we're overlaying it on real regions. Remember, this is the Mesoamerican reef region in the Caribbean. Now we're looking at that and saying, okay, great. There are lots of reefs people are already protecting. How do we use this information to identify which places and what kinds of reefs we should be protecting going forward? How do we build a portfolio of diverse reefs that are interconnected in this system and are really built on a foundation of communities who have figured out ways to protect their reef going forward? We're testing this out in the Mesoamerican reef. We're investing a lot of our time and effort there because we've got a great set of partners throughout this region. We've got a lot of work underway, and we think this can actually be a real model for how do you design adaptation networks for coral reefs around the world. But ultimately, what we're really interested is in thinking about coral reefs around the world. This is the distribution of coral reefs around the world in a few different biogeographic areas. Each and every one of these biogeographic areas includes these same kinds of coral reef regions where people are trying to find conservation solutions. And what we're trying to figure out is how do we go from a lot of good work that's happening right now fairly organically to really thinking about how to organize that work in a way that drives the process of adaptation and allows reefs to have an ability to adapt to the environmental changes that are coming. The reality is that there is a lot that's riding on our ability to get this right, and it's really pretty urgent. We've got a few decades to a century to solve these problems because of the pace of environmental change. All of the wildlife that's on reefs, the millions of different species, from turtles to sharks to corals to shrimp, all of them are going to rely on our ability to get these solutions right and continue to have coral reefs around the world. And even more importantly, people in communities all over the world are depending on us getting this right. And so we feel a really strong sense of urgency. We feel a really strong drive to try and make sure that we can get these solutions to scale all the way across the world because our time window is the one that's right in front of us. So I wanted to close just on one last thought before we go to questions, and that is, well, what can you do? If you are a diver and care about coral reefs, or if you're thinking about these issues, what is it that an individual can do in this system? The first is, individuals can do a lot on the mitigation side of that equation. You can make decisions about your own carbon footprint or your own use of greenhouse gases. You can also make decisions through your place of work. I know Google thinks a lot about these issues around how do they use energy efficiently and how do they think develop the organization as a good actor in terms of climate change around the world. This is also showing more and more in policy. I mentioned that all countries but one are part of the Paris Accords. That one happens to be our country, which isn't proving to be a leader right now at the national scale. It is proving to be a leader at the local scale and the state level and at the level of industry. And so there's a lot of ways of getting involved in those processes on the mitigation side. On the adaptation side, the main kinds of things we can do are the kind of work we do working with communities or other organizations do working with governments to try and put in place policies that allow local reefs to be well protected and those protections to exist across these different networks. That can include supporting conservation organizations. It can also include choosing to go and visit these places. A lot of these places are dependent on tourism economy, and so if you're going to be traveling anyway, I would recommend go to a place that's trying to protect their reefs. Go see those reefs, learn about what they're doing, learn about those local organizations, and see if you can get involved. You can get directly involved through those organizations. You can get directly involved through other organizations in protecting those reefs locally that are going to add up to those adaptation solutions while we get a handle on climate. And I'll stop there and take questions. Thank you.
Hi, I had a question about the adaptive reefscape. You showed like a diagram for it, but have you started implementing any of it yet, or is it just plans right now?
So, yes. The modeling that I described to you earlier is a project that's underway right now. And what we've done is an initial set of models. What we're doing is we're getting an initial set of what I would call rules of thumb. How do you design these things in general? The next phase is actually going to say, okay, let's take a region like the Mesoamerican region and let's map out where the reefs are and let's figure out what the design should look like for that place. We haven't done that analysis yet. That's coming in the next year. But in the meantime, we can already take a look at that region with a screen for what kinds of things are we looking for. I mentioned our focus on Honduras and all those initial dots in Honduras. That's because when you look at the places where intensive conservation actions are going on right now in that region, they're really focused on Belize and Mexico. And what's happening right now is that you've got this giant hole in that reef system where you're missing a lot of the connectivity because those reefs are well connected to each other, probably also missing a lot of the diversity. And there's some very unusual reefs in Honduras, so we've already decided to place some bets on and try and make sure that those unusual reefs are part of that portfolio. So in general, absolutely yes. We're also working with a lot of the partners throughout that region, governments, NGOs, others, funders, to think about how do we get this solution at scale. And so every step is in that direction. The next level is going to be a tailored analysis to that particular region, looking at the connectivity matrix, the distribution of habitat for that region, and then analyzing that compared to the work that's already going on and saying, how does the current distribution of effort perform over time? And are there areas where if we expanded our effort just a little bit, we could get really big bang for our buck in terms of adaptation of the system as a whole?
Are we talking as something as big as maybe transplantation?
That's a great question. I didn't talk about it specifically in this talk, but it is an area that's getting more and more attention in our field. And it's a very direct way of trying to solve this problem. If the corals are declining on a reef and you want corals on that reef, what if you just grow some corals and put them on that reef? And the thinking on it is very linear, and we have every reason to believe that that can be done. And people have done it over and over again. The problem with it is a scaling problem. So we did a back-of-the-envelope analysis on that Mesoamerican region, which is just a little tiny fraction of the world's coral reefs. And we looked at how many corals cover a certain area on the bottom and how much habitat, and just said, how many coral colonies are in that region? And the answer ends up being probably billions. So there's probably billions of these colonies. To do transplantation is very expensive per unit. So if you're going to collect a coral, you're going to grow it in a tank, you're going to run the energy to keep that tank moving, you're going to get it to a size, you're going to take it as a diver underwater and you're going to put it on the bottom. Each and every one of those corals is going to cost you $1 or $10 or more. Most of the transplantation experiments that have been done so far tend to work in tens of individual corals or hundreds of individual corals, or at the higher end, thousands. And it's probably multiple orders of magnitude off the scale that's really going to make a difference to the population dynamics in this region. It's kind of like thinking about humanity, right? Humanity's got somewhere short of 10 billion people. How many new people would you have to add to the planet to really change our population dynamics? It's not going to be a few thousand. It would have to be a much, much larger number than that. And so while I think there's a lot going on that's promising on the restoration front, there hasn't been a real ability to solve the scaling problem. A lot of people are working at how do you make it cheaper and cheaper and cheaper so that you can do more, and I think there's some promise in that. The other side of it that's interesting on the restoration front is that people are beginning to say, wait a minute, what if we identify some of those unusual corals? And what if we put those corals out there and essentially speed up the adaptation process? Let's pick the winners for the future. Let's grow those ones, like the really temperature-tolerant corals, and put those out on the reef. I think that's more promising, but one of the things that our analysis shows on the different strategies is that when you start picking a narrow set of winners, that's when you start to get into trouble, because that's when your assumptions are likely to be wrong. What you could do if you wanted to pick the most temperature-tolerant corals is you could essentially create a monoculture problem. You could select those corals for that particular trait, but you might be losing other traits in that process. We know how to do this in agriculture, and this is one of the problems we've gotten to in agriculture, is by designing plants or animals for very, very specific purposes, they become bad at other things. And so you might be able to design a coral that's really good at dealing with high temperature, but maybe it's susceptible to disease, or maybe it doesn't do well in storms. And it's the combination of these different traits which is probably going to be what we're going to need for successful reefs going forward. So I think we're just beginning to ask some of the interesting questions there about, can we actually drive the evolution of corals by selecting for particular traits, and can we do that in a way that protects our diversity portfolio? What I would say is if we're protecting the diversity portfolio in the process, that's a really good step forward. One of my concerns about this area, though, is that the resources we're currently putting into trying to solve these problems locally could shift to trying to grow corals. And if we haven't resolved the problems that I was talking about earlier around things like overfishing and pollution, we don't actually have good environments to transplant those corals into. So what I would recommend is let's make sure that we're doing that work. Let's make sure we're creating those good local environments that are going to allow corals to flourish. And if we want to augment that by restoring corals actively, let's do so. But let's not kid ourselves into thinking that the costs of that are going to be small or easily scalable.
Thank you. So you mentioned the village in Fiji, and a lot of us here have to influence either our coworkers or outsiders or users that there is a better way to do X, right? But human nature is what it is. I wanted to understand a little bit more about how you actually go about from the sort of headline of you can do just as well with tourism than fishing. How do you actually implement that? Like a little bit more on the mechanics of that.
The bulk of our program staff are what I would loosely describe as community organizers. They're people who live in Fiji, or they live in Honduras, or live in Indonesia, and they're part of that community. And what they've decided on their own is that they want to be part of solutions that are going to benefit the community for the long term. How do they manage their activities? How do they have economic development while continuing to have these other benefits? And one of the beautiful things about working with that particular population is that that population is actually quite keyed into the interests and the incentives within that community. One of the big mistakes of conservation over the years has been the assumption that people like me, who are Western trained, who grew up in North America, that I'm going to know what's best for a community in Honduras, or I'm going to know what's best for a community in Fiji. The reality is I don't. I can understand how coral reef works, how coral reefs work. I can understand what's been tried in other places, but the community actually has to be the one to think about what they want for themselves. The key to making something like this work, usually though, is trying to find the place where the incentives line up. And if there's a strong incentive within the community to try something different or to reinforce something that's different, that's when it's likely to work. And if those incentives don't exist, it doesn't matter how good your idea is, the community actually has to be able to benefit from it. So in the Fijian situation, that community, independently, they knew they had a problem. They knew that they weren't catching the fish that they used to be able to catch. The fishermen in the community were saying, when I was a kid, and they sort of realized, wait a minute, what's going on? At the same time, that community was seeing fishers come in from other villages and fish their reefs. Now, in that case, I told you there's a property rights system where that community actually owns that resource. And they started to say, wait a minute, this has gotten so bad, how do we solve this? How do we take action for our own reefs in a way that allows us to have the kinds of fishing we used to and the kinds of benefits we used to? And so they came to us and other groups to say, can you help us figure this out? And so we'd seen, for example, dive user fee systems work in other communities. So a community might say, hey, we're going to make this particular area of reef a protected area, and we're going to allow it to fill up with sharks and big groupers. But if you want to come here as a tourist and you want to see that because you're interested in that wildlife, we're going to charge you a nominal fee to do it. Maybe $10, maybe $20, and then you can go and see that. Well, if you're paying a bunch to be a tourist and go to a place like this, it doesn't really matter, this small fee. But those small fees can be really important to a community like this because in the case of the community in Fiji, some of those fees went directly into community projects, like scholarships for children or like building a new community center. And that community could then tie their interest in protecting the reef with a direct economic gain. Those dollars also go to managing the park. And so if you can create a system like that where the community is saying, hey, we want something like this, we want a different set of access to our resources, we see these benefits on fisheries, we see these economic benefits. How do you design a system to do that Well, we've got good models around the world of communities who have been down this road, who have built these systems, who have built out the business plans, who have built out the enforcement mechanisms, so that you can apply those same tools from one community to another community. But it absolutely requires that initial step of a community that wants to do something about this. It's much more difficult, and frankly, it's not necessarily worth it to go into a community that's not looking to solve a problem, that says everything is just fine, and try and impose a solution. That doesn't make any sense. The market out there, if you're looking for communities that want to solve these kinds of problems, is really good. You know, that's one of the blessings and curses of our work, is that there are more communities who want this kind of solution than we have resources right now to be able to help them design it. If every community has to do this de novo, if they have to figure it out for themselves, it's not going to be very efficient, it's not going to be very effective. If we can take what's worked in other places and compare that to what the individual needs of the community are, we can find things that are more scalable.
So you showed a map of all of the coral reefs around the world, and a lot of them are centralized. I saw around the coastal regions for the United States. Yeah, that one. So, and then you had also showed a picture of the Maui issue, where we had the toxins coming in from and also the sediments and the nutrients. But from this standpoint, what has the Alliance done in terms of legislation and potential rulings on that to help curb those bad behaviors?
Yeah. So every nonprofit organization has to decide what are the things that they are going to work on and what do they want to really specialize on. We have not made a decision to specialize on things like legislation. We actually have lots of great peer organizations that work things like the US national government or national governments in other countries to try and create legislation for things like protected areas and things like that. So our work is much more community focused, which is part of the overall set of solutions. It's not everything that needs to take place. What we tend to find in most places around the world is that sort of larger scale legal framework is an enabling condition which can allow conservation to proceed. By itself, it doesn't usually get us to solutions. I would say particularly in developing countries that might pass great laws, but then they don't necessarily have the mandate or the resources to really implement or enforce those laws. What we find is that in a lot of these countries, communities can then use that legal framework to assert a set of protections or management systems over the resources that are important to them, oftentimes through some kind of co-management structure, where the government will say, gee, we recognize this is our law, but we're not really implementing it. If the community wants to implement it, we'll try and figure out ways to work with you. So that's the space that we work in more than the setting the legal frameworks in the first place. A lot of the countries we work in actually have very progressive laws around this. If you look at like Honduras, for example, has some very progressive laws around protecting coastal resources, and they've established very large parks. And if you just look at that on paper, you'd say, wow, this is great. The problem is that 95% of the work remains to be done after that, which is how do you translate that into a set of durable, effective practices that are consonant with the community's interests so that they'll be maintained moving forward. In the US, you mentioned some of the coastal areas in the US. The US has a mixed record on this. For coral reef protection, I would say in some cases we see more progressive policies sometimes in developing countries than, say, Hawaii, particularly around things like fisheries. Hawaii has a lot of difficulty in changing fisheries rules because there's a lot of user groups who all currently access the resource and none of them want to give up that resource. And that makes sense from their perspective, but it creates an ongoing problem on the reef. The US does have some big coral reef protected areas. Hawaii is interesting because a lot of the really degraded reefs in Hawaii are the ones you would see if you went to Oahu or Maui or Hawaii Island and went snorkeling. Those are the high islands of Hawaii, which is where most people would visit. If you go past those high islands, there's actually a series of atolls that go far, far up into the North Pacific. So here are the high islands of Hawaii right in here. And then there's this long island chain, which is sometimes called the Northwest Hawaiian Islands. Actually, George W. Bush turned it into a national monument. It's called Papahanaumokuakea, which essentially protected that entire set of islands, that entire chain of islands, which is one of the biggest protected areas on the planet and one of the most significant ones for coral reefs. And then it was expanded under the Obama administration. We'll see if it holds.
So you mentioned that you have basically more demands for getting your consultation working with these communities than you can handle. So I was just wondering, what are your thoughts in trying to, I guess, scale your organization or the number of communities that you're reaching out to?
Yeah, there's a number of different dimensions to that. One is we work with lots of other organizations, and we have a fundamental belief in partnerships that, the Coral Reef Alliance isn't going to solve these problems on our own, and it's silly for us to think so. Instead, we work with lots of different conservation organizations to try and get to this scale collectively. Another piece of it is we need to figure out how to replicate efficiently, because if you have to start over in every place and say, okay, now it's a new problem, let's begin from zero, then you're using basically the maximum resources to get the job done in any one place. And so we're always looking for opportunities to take ideas that worked in one place and use them to build sort of word of mouth momentum where a community next door looks and says, hey, I want one of those, why can't we do that? And at the same time, build those tools that are transportable, so that in the next community, you have a built-in already interest in trying the same kind of solution. You've got tools and techniques for doing it. You can implement the same thing more cheaply. So there's some scalability that's built around that. The other piece is, as a nonprofit, we're also always looking for more resources to implement at scale. There's not going to be a silver bullet here. There isn't going to be just a viral solution that can cruise and expand all on its own. At the end of the day, it is going to take a certain amount of heavy lifting in a lot of communities to get to these kinds of solutions. The question is, how do we do that in a coordinated way that takes advantage of all the different players that are out there, and in each and every instance does it as efficiently and effectively as possible with the minimum amount of resources so we can apply those resources somewhere else. Thanks, everybody.